Hello guys, welcome in online learning the subject kinematics and theory of machine. We are studying the chapter friction. In this lecture, in previous lectures we were studying the what are the types of friction, what are the classifications of that, and we have gone through the laws of static friction, and thereafter we studied what is limiting friction. Then we also learned that what is normal reaction, mm, which is the perpendicular from the surface wherever the load is applied. That is called normal reaction. And today we are going to start with the laws of dynamic friction. And now remember that what is static friction and what is dynamic friction. The difference between the two is the motion between the two surfaces. Now some student asked me that in dynamic friction, in our example, uh, one object was moving and one was stationary, that was sofa and the surface. The sofa was moving and the carpet, the floor was stationary. Now it is let me remind you, let me tell you that it is not necessary that which surface is moving. We are only interested in relative motion between them. If one surface is moving, one object is moving and another is stationary, then also the dynamic frictions comes into picture, because we are interested in the relative motion between the two objects. To start with, again let me remind you that in static friction we are only dealing with the objects which are stationary. Means that if the object is not moving and we are applying the force to it, friction acts between the surfaces in contact. But when this object starts moving, dynamic or kinetic friction comes into picture. Starting with the laws of dynamic friction, first law says that force of friction is always opposite to that of motion of the body. Now we have already gone through this law, I mean that this phenomenon of friction to act always in opposite direction. We have already gone through that. Friction always acts in the opposite direction to that of the motion of the body. Means if you pulling or pushing the object in one direction, friction always acts in opposite direction. As we can see in this image, it always acts in opposite direction to the motion of the body. So remember that this law was also introduced in the static friction, because it is the general law for the friction that it always acts in opposite direction, as shown in this image. Another law says that the magnitude of kinetic friction bears the constant ratio to normal reaction between the two surfaces. Means again, the ratio F upon Rn is equal to constant, which we have already seen in previous static laws of friction. Laws of static friction. We have already gone through this. That magnitude of kinetic friction. Now it was the magnitude of static friction when we have studied the laws of static friction, and at this time this is the magnitude of kinetic friction, but the law remains the same, that F upon Rn is equal to constant. This is for the dynamic friction. Third law says that for moderate speed, force of friction remains constant, but at higher speeds it decreases slightly. Now what does that mean? uh, Let me give you some example. If you have experienced the thing that when you are riding your two wheelers very fast on some rough road, uh, the roughness of the road affects less to you while you are driving at some higher speeds than you are riding at a lower speed. Means if your speed is low, you will experience the bumps and the roughness of the road much more than you are riding at the higher speeds. Now this applies to friction as well. Means if the speed is low, means the relative speed between the two surfaces where friction is applying, means the friction is working, will be if the speed is low, means the friction will be more, and at higher speed it decreases slightly. Now this doesn't mean that as you increase the speed the friction is decreased. No, that's wrong. If the speed is increased, the friction decreases slightly and then it remains constant forever, whatever the speed is. So these laws are for dynamic friction, that the force means you have to remember like this, that the force opposite is sorry the force is always in opposite direction of the motion of the body. F upon Rn is equal to constant, and at some higher speeds the friction decreases slightly. Okay, so this was the laws of dynamic friction. Now let's move ahead and go for the laws of solid friction. Now you if you remember that we have studied that during the classification of the friction. Uh, First there was the type of friction was static and dynamic. Then according to lubrication we classified the friction according to dry surface and lubricated surface. So if the lubrication is present or the lubrication is absent. So if the lubrication is not present, means the lubrication is absent, the friction will be called as the dry surface or solid friction. So this is what our next laws we are going to study, that are laws of the solid friction, which says that which says that force of friction is directly proportional to normal load between the two surfaces. Now this means that if the normal reaction is more, the friction will be more. Now what is this normal load? It is the same as the normal reaction. We can say it normal reaction. If the object resting on the surface is heavy in weight, the friction will be more. Okay, because remember that F upon Rn is equal to constant, right? So this is the Rn, and this is the normal reaction. So there is a relationship between that the friction is directly proportional to the normal load between the two surfaces. Means if the if the load is more, if the normal reaction is more between two surfaces, the friction force will be more. This is for non-lubricated surfaces. We are studying the laws of solid friction, right? Next law says that it is independent of area of contact surface for a given normal load. So if let me give you an example. If there is a cube and it is having a surface area of 1 feet by 1 feet, means 1 feet square, uh, and the weight is of 5 kilograms. Okay, so and there is another object of same 5 kilograms, but the area will be 1.5 feet by 1.5 feet. Okay, so the area of second cube is more than the area of first cube. Means the contact means in which on which sorry on which these the two cubes are resting is different, but both are having same 5 kilograms of weight. So will the friction be different for these two cubes? The answer is no, because the area is not playing a role in the case of friction. So no matter how big or small the object is, or no matter how large the area is covered by the object on the surface on which it is resting, so it doesn't matter, right? If the weight of both the cube or both the object is same, the friction acting on both of them will be the same. So this is the second law, that it is the friction between the two surfaces is same till the till the weight or normal load is the same. Now I'm mentioning the weight many times is because that is it equals to normal load, right? If the weight is more, the normal load will be more, because normal load is equal in opposite to the weight of the body. So that's why I'm mentioning the weight, but the normal load is the correct word for this. Now third law says that force of friction depends on material of contact surface. Let me repeat that: the force of friction depends on material of the contact surface. Now okay, this is because the surface area doesn't matter, but the surface roughness matters. If the surface is of sponge material, if you say, or it is a polished steel material, the friction will be more in the sponge material, right? Because it is of a different kinds of material, right? So it is obvious that if the surface roughness changes, or in other words, the material changes, the force of friction will change accordingly, right? And the final law says that the force of friction independent of relative velocity of sliding. Now in solid friction, it says that the force of friction is independent of relative velocity of sliding. Okay, so no matter how fast or slow the objects are moving with relevant to each other, the frictional force will remain the same in all cases. Now you will think that we have studied that the frictional force slightly increases with the slightly decreases with the increasing in uh, velocity of the motion, speed of the motion, speed or velocity of the motion. But here it is mentioned that the force of friction is independent of relative velocity of the sliding. Now now this is because these laws of friction is for solid friction only, means the surface is completely dry. There is not a 0.01% of uh, fluid is present. Okay, so that's why here it is mentioned that it is independent of relative velocity of sliding. Now let's study laws of fluid friction. Now fluid friction is when the two surfaces on which we are interested to study the friction is lubricated. Means you are pouring the oil in your engine, this called engine oil, to reduce the friction and wearing or heating the parts. That is to reduce the friction, right? So this is that kind of friction we are what we are studying next is that kind of friction where we are lubricating the surfaces to reduce the amount of friction. So first law says that force of friction is almost independent of load. Now remember, in earlier while studying the laws of solid friction, it was said that the force of friction is directly proportional to the normal load between the two surfaces. Now here in fluid friction, it is said that it is almost independent of load or normal reaction. This is because the fluid film, thin film, thin film of fluid is incorporated between the two surfaces on which the friction is acting. That's why here it doesn't matter that how much heavy or light the object is, or how more or less the normal load between the two surfaces is, the force of friction is independent of them. Second law says that the friction reduces with increasing in temperature of lubricant. This is also important that which type of lubricant is used and what temperature at which the lubricant is. So it means friction reduces with the increasing in temperature of the lubricant. So if the lubricant is hot, the friction will be less, and if the lubricant is somewhat as less in temperature, the friction will be more. Now let us not go deep into that why it happens. There are many reasons of happening this. Now third law says that it is independent of substances of bearing surface. Means bearing surface means on which the friction we are interested in, or on which the friction is acting. Now it is independent of surface roughness, you can say, because obviously this is true because we are applying lubricant between the surfaces, right? That's why the friction is not directly acting on the two surfaces, because the lubricant is present. So why does the surface matters? Okay, because that's why we are applying the lubricant, na? That is why there is no importance of bearing surface, means on which the friction is acting. So if you apply the lubricant, no matter what surface is, it will not change the amount of friction between them. And the last law says that uh, it is different for different lubricants. Now this is obvious. If you apply oil or if you apply grease, that will be different for both of them. Okay, so it is different for different lubricant. It is self-explanatory. Now remember that we have gone through the term normal reaction and frictional force. That was limiting friction. When we gone through that, I said that the frictional force to the normal reaction, this ratio is constant. Okay, now this is important term called coefficient of friction. Okay, this is very important in any kind of friction. That is mu, it is denoted by mu, is equal to F by Rn. The suffix n is representing normal, means the normal reaction is called denoted by Rn. The frictional force is denoted by F, and the coefficient of friction is denoted by sine mu. So this is the coefficient of friction. It is the ratio of limiting friction to the normal reaction between two bodies. Now remember that the F is called the limiting friction. That is the amount of friction at which the body just tends to start moving. Remember that if we push any object, it doesn't move until the amount of friction is reached to limiting friction. Okay, so that is the limiting friction. Sorry, the coefficient of friction. Okay, so it is enough for now. We will study the next points, that is the limiting angle of friction and angle of repose in next videos. So thank you for watching. If you have any doubts or difficulties, you can contact me in person. Thank you.